Hi, I'm Miss Hall, and this is lesson 1.5, Properties of Real Numbers. It's going to be a lot of properties we're going over. Let's begin with the properties of equality. We have the addition property of equality, which states adding the same number to each side of an equation produces an equivalent equation. The subtraction property of equality, subtracting the same number from each side of an equation produces an equivalent equation. So there's even a sample here. If A is B, then A minus C is B minus C. That stays equivalent. I can add one over here. If A equals B, then A plus C equals B plus C. That doesn't change the equality of this equation. We have a similar thing for multiplication and division. The multiplication property of equality means multiplying each side of an equation with the same non-zero number produces an equivalent equation. So when you get to multiplication and division, you're going to see this non-zero. Zero has funny properties that mess up this the equality. So we have here, if A equals B, then A times C equals B times C. And then dividing each side of an equation by the same non-zero number produces an equivalent equation. So if A equals B, then A divided by C equals B divided by C, as long as C is not zero. So I should put the same stipulation here, as long as C is not equal to zero. We use these properties in solving equations. So example 1 is solve the equation justifying each step. We have negative 3 times a number plus 5 is 26. So let's go with negative 3 times a number. I'm going to use x to represent the number, plus 5 equals 26. Let's get that 2 in there. And so when we're solving, we want to isolate the variable. That is our goal. Our goal is to isolate the variable. And to do this, let's first subtract 5 from each side. And we can do that and not change the equality because of the subtraction property of equality. So I will justify this with the subtraction property of equality. Let me finish writing that. And when I subtract 5 from both sides, I get negative 3x. 5 minus 5 is 0, equals 21. So I want to get rid of this negative 3. So to isolate that x, I do the opposite of multiplying by negative 3. I divide by negative 3. And so in this case, I am using the division property of equality. And then I get x is equal to 21 divided by negative 3 is negative 7. It is always a good idea to check your equation. Here's my fancy check mark. So we say negative 3 times negative 7 plus 5 equals 26. Let's make sure this is true. You can see I just rewrote the original equation, substituting in our value for x. Negative 3 times negative 5 is positive 21 plus 5. Does that equal 26? Yes, it does. So I got the right answer. Okay, we move from properties of equality to properties of real numbers. If A, B, and C are real numbers, variables or algebraic expressions, then the following properties hold true. We begin with the commutative properties of addition and multiplication. For the commutative, I like to think of a commute, where you go to school and then back to school. And the distance is the same when you go to school and back from school. That helps me remember that the commutative property of addition is that you can reverse the order and it remains equal. Those both result in the same value. Same thing with multiplication. A times B is the same as B times A. In this example column, we'll throw in a quick example. So 2 plus 4, for example, is the same as 4 plus 2. Both sides here equal 6. Let's pick 3 times 5 is the same as 5 times 3. Both sides equal 15. So that's the commutative property. Again, I try to remember it based on commute. Going one way and the other helps me think of just switching the order. We've got many more properties to review, so let's keep going. We have the associative property of addition and multiplication. So associative property, you need to remember parentheses. And these properties state that if you are adding, in this case, 3 values, putting parentheses around the first 2 results in the same answer as putting parentheses around the second 2. In other words, if I had, and I'm just using any numbers here, 1 plus 4 plus 3, and I put 1 plus 4 plus 3, if I chose to add parentheses here versus parentheses here, I would get the same result. This would be 5 plus 3, and this would be 1 plus 7. Both sides equal 8. Same things happens with multiplication. I'll use smaller numbers so I don't have to pull out a calculator. I'll use 1 times 2 times 4 and 1 times 2 times 4. Parentheses around the first 2 versus the last 2. Right, if I'm using GEMDAS, I do the grouping symbols first. So I get 2 times 4 equals 1 times 8, and 8 equals 8. Great. Now we have the distributive property of multiplication. If you have a situation where you have A times the sum of B plus C, or A times the sum of B minus C, you can distribute that A to everything inside parentheses and get AB plus AC, or in this case, AB minus AC. Let's do an example here with values. I'm going to choose some negative numbers, so negative 3 times, let's do 4 plus 2, or negative 3 times 4 minus 2, and let's just use the distributive property to multiply negative 3 to all terms inside parentheses. So we get negative 12 minus 6, because a negative 3 times a positive 2 is a negative 6. And here we get negative 12 plus 6, because a negative 3 times a negative 2 is a positive 6. We move into identities, the additive identity and the multiplicative identity. Identity, I think of a person who stays true to themselves. So any number plus 0 results in the original number, right? You know this. Any number, let's put 34. If I add 0 to it, it remains 34. For multiplication, any number times 1 equals the original number. So let's choose a wild number. 83 times 1 stays 83. You stay true to yourself. That's how I try to memorize the identity properties. Then we have the additive inverse. I'm going to write this one out. Any number plus its opposite, I'll put that in quotes, is equal to 0. Right? So if I have, say, 9 plus its opposite, negative 9, I get 0. Let's do multiplicative inverse. Any number times its reciprocal is equal to 1. So let's say I have the number 7 times its reciprocal 1 over 7. This would give me 7 over 7, right? I put this over 1, which is really 1. And finally, the multiplicative property of 0. Any number times 0 is equal to 0. Let's pick any number. What number have I used in a while? 5. 5 times 0 is equal to 0. Let's see what we're going to do with these properties in the try it. You're going to go through and try these and unpause the video when you're ready to check. Let's rewrite this first equation so I just give myself a little more room. And in trying to isolate the variable, the first thing I'm going to do is add 3 to both sides. So I am using the what's it called? The addition property of equality. When I add 3 to both sides, I get x over 4 equals 5. And now I want to get rid of dividing by 4, so I do the opposite of dividing by 4, which is multiplying both sides by 4. And I can do this because of the multiplication property. Of equality. This gets 4x over 4. And 4 divided by 4 is 1, so I'm left with x equals 20. And I like to check it, so here let me do my fancy check and say, okay, so the original equation, if x is 20 divided by 4 minus 3, does that equal 2? 20 divided by 4 is 5 minus 3, does that equal 2? And yes, it does, 2 equals 2. Part B. Which property of real numbers is illustrated by the following equation? So what we have here, I recognize as the distributive property. So this is the distributive property. This is the distributive property of multiplication.